Cloud SQL is a relational managed database service for MySQL, Postgres, and SQL Server with replication support. It has automatic failover with read replicas. It has point-in-time recovery for restores, automatic scaling storage for up to 30 terabytes with SSD or HDD. We have data encryption at rest and in transit. It has simple pricing for CPU, memory, storage, and traffic. This one requires the most level of management out of all the providers, such as Spanner and AlloyDB, but it is very cost effective. A Cloud SQL instance is a virtual machine on Google Cloud that runs your database. You can connect to the database using a static IP address. It provides a consistent endpoint for the application to access the Cloud SQL instance. A high availability standby virtual machine in another zone to take over if the original VM fails can be added, I suppose. The database is the core service, so that could be MySQL, Postgres, or SQL servers. It can store the database with durability and scalability via a persistent disk, or I suppose a hyperdisk, as hyperdisk is preferred these days. It has logging and monitoring built in, so you can track its performance, and it supports operational tasks. So there you go. Hey, this is Andrew. In this video, let's take a look at Cloud SQL. So Cloud SQL is a way of deploying managed SQL databases. There's also Spanner, which is SQL-like or SQL compatible, and that's fully managed. But Cloud SQL is just your usual databases here. There are different ones that we can deploy. We have MySQL, Postgres, etc. I personally like Postgres, so that is normally what I would like to deploy here. And you can see right away that we have some options where we can go here and just start spinning one up here. Let's go ahead and walk through the steps ourselves so that we know what we're doing. Very simple choices here. Down below we have AlloyDB for Postgres. And this is also a really good option. But we are going to take a look at Postgres first and ignore MySQL. No one who's using MySQL anymore. So we have a couple options here. We have Enterprise Plus or Enterprise. It should tell us the cost here down below. And it doesn't because we don't have everything chosen. So I'm not trying to spend a lot of money. So let's just do normal enterprise. We are going to use the development preset. And we have 30 total without usage discount, 30 cents. I don't think it's that cheap, but whatever, that's fine. As long as it's not costing me a lot of money. And so the latest version is PostgreSQL 17. We're going to call this my PSQL server. The password, it's going to be pretty finicky. So I suppose we'll let it generate a new one here. I'm going to copy it out and just dump it here. Nope, didn't copy. Let's go back over to here and show it. I'm going to go right click copy. And I'm just pasting here, right click paste. So we're just holding on to that password for a little bit so we don't have to figure it out. I don't like complex passwords when showing stuff here, but they do have the generate button, so why not? There's obviously a password policy that you can enforce here. I'm going to go to Toronto, as that's where I like to deploy things, assuming it's available. It's all about availability. We are looking for North America, Northeast 2. Single zone is fine for me. If you want more availability, you can go ahead and do that yourself. Customize your instance. So let's go down below here and take a look. So here we could choose our machine image. I will use shared. I want this to be cheap. I think that these presets are already set here, and so maybe the cost might have gone up. But I just want to go through here and show you how to make it really cheap if you're not using the presets there. So we're going shared core. We're going really small here. For our storage options here, HDD is even cheaper. I don't need a lot. We'll do 10 gigabytes. For connections, we have public and private. I'm going to want to connect to this publicly, so we'll have that as an IP address here. You can specify CIDR ranges. That's fine as well. We're going to leave that alone. Google Cloud Service Authorization allow Google Cloud Services like BigQuery to access data. We might want to do that later on. For security, we're going to leave it so that Google manages it for data protection. I'm turning off backups. Again, we're doing this just for to demo, right? I don't want it to prevent instance deletion. That might get annoying. I don't want to retain anything right now. Let's go to maintenance. We'll just say any. It doesn't really matter because we're going to just connect to this and delete it afterwards. Query insights. Helps you detect and diagnose performance issues. That can be really useful, but I'm not turning that on here today. And we'll go ahead and take a look. And so we really have this, this is hourly cost estimator, so it's not showing us the monthly cost. Okay, and we'll go ahead and create that instance. And so instantly we're over here and it's saying the instance is being updated. So I don't believe that it is ready. If we go over to SQL here for instances, we have the status here and it says instance is being updated. So we're going to wait till I think that this icon changes and it's just a solid green one. Could be wrong, but we'll wait here a little bit, okay? All right, our Postgres server is apparently ready. We'll want to go ahead and connect to it. Just to make it really clear where to find that, I'm going to go here to SQL. All right, so I'm just kind of backing out and making this a little bit easier. We're going to click into here. On the left-hand side, we have connections. And so we're starting to get connection information. So this looks like a connection. It's just a connection. Yeah, it's just a connection name. It kind of looked like a connection endpoint, but I wasn't exactly sure there, but now I am. So it has a public IP address, so technically it should be accessible. Just taking a look here. Yeah, so I think it should work. So we're going to need some way to connect to this, and I do have this environment here, but I'm not sure if I have that set up. An easy way to connect to a database is using Table Plus. This is one piece of software you can use. It has a free tier. I've been using it for years, and it's fine. So we'll go ahead and open that up. And if I don't have it installed, do I not have Table Plus installed? Well, look at that. I don't have it installed. So we're going to go ahead and install Table Plus. There's probably like free ones also within extensions, but this one just happens to work easily. So we'll go ahead and do that. And hopefully that works without problems for us. So I'm just going to go ahead and get this set up here. Okay. I'll be back in just a moment. All right, so let's go ahead and launch Table Plus. And so now we are here in Table Plus. It can take a connection URL, but I think it depends if you're on Mac or Windows. So we're going to make a connection here, and I want to make a connection to a Postgres database. So you can see it supports quite a few things. And so this will just be my, or like SQL Cloud GCP. And so we're going to need to start grabbing information and putting it in here. So obviously one thing is the password. So I'm going to go grab that before I lose it. As I place it in a very precarious location, we're going to put the password right there. The next thing is the name of our connection name. So here, so really that's the whole name. I keep thinking that this is the host, but we'll go ahead and copy this. And I'm going to paste that here. I'm trying to think, what did we set as the username? I mean, I don't remember setting any username, so over here, I guess we'd have to set up set up users, right? So here we have Postgres, and there is no password set to it. Well, wouldn't the password be the password we set for the database? It would be, right? So I'm going to go ahead here and copy the Postgres user. You're normally supposed to create an additional user and log in, but it's totally fine if we don't do that. We'll go to databases because you can have multiple databases within here. The only database that's in here is the default database. I like how we have the options to create stuff here, and we can try that in a moment. And so we're basically logging in as the most permissive user that we can here. And so we'll go ahead and test this connection. So this driver error, unknown error. Well, that doesn't really help me too much. And we'll give it the port 5432. We'll test it again. So I'm not exactly sure as to why. It's not really giving us a whole lot of information. So if that doesn't work, let's go ahead over here. Normally it's easier than that. We'll go over to connections and we'll go to test connectivity. And I don't know if this is too much work. No, I think it's connectivity to the database, so it's not really what we want. But we have a public IP address. Connection name. There is also a public IP address. So I'm going to go ahead here and provide that there. That might actually make more sense. And we'll test that. I'm so used to there being a host name, and so maybe I just was a little bit too eager to do that there. And so I don't see anything coming back from our test, so I'm not sure if it worked or not. We'll go ahead and maybe save this, because maybe it did work. Here it's specifying that this is local. It's technically not local. It's unknown driver error. We'll just ignore that for a second. We're going to go to production here. We'll test that again. 5432, that's standard port, passwords in here, database is in here, Postgres is our user. We'll go ahead and hit connect. Did this connect? It didn't error out. And we don't see anything here. So what I'll do, unknown driver error. I'm not sure about that. But what we'll do is we'll go ahead and make a new database. And we'll just call this tasks. Okay. You cannot create a database since there's a pending operation. Oh yeah, okay. So now we have our tasks. And I'm going to go back over to here and let's see if we can refresh or see more information here. So I'll just close that out. I'm going to edit this. We're going to choose the database as tasks. And we'll now connect to that. Okay. And yeah, it looks like it's not really establishing connection. So I don't think that is, I don't think that's working. So just give me a second here. I'm going to try to figure out how we can get connected to this. So if our external connection is not working for whatever reason, I know on the overview page, we also have this option here. I think it populates this so we can actually log in. Let's see if we can get in this way. The other thing is like, does our firewall rules allow folks to connect to it and do firewall rules apply there? I'm not sure. So we have Cloud SQL connect MySQL server, Postgres quiet. We'll go ahead and hit enter. And here it says the SQL admin API is not being used before or it is disabled. So that could be maybe part of the reason as to why we're not able to access it. So here, what I'm going to do is we'll type in, let's see if we can get the API this way. We'll try this. Okay, so we'll go ahead and activate that. Okay, so that's now activated. You can, obviously, there's lots of ways to enable permissions, and that's just the way we did it here. So we'll go ahead and we'll try this again. And so now say allowing your IP for incoming connection for 5 minutes, working. And it's thinking. We'll give it a moment there to think. It is progressing now, connecting database with the SQL password. Oh, so we need to provide the password, which is a bit of a headache, but we'll go ahead and copy this. We'll go back over to here, and I'm going to go ahead and paste it in. I'm going to hit, oops. I'm going to go ahead and hit enter here. It should have been pasted in, and so now we're connected to the database. And if we list all databases here, or was it LS? DLS? That was LS for list databases. It's been a while, so list all databases, Postgres. It's a \L, right? Yeah, it's \L. But the point is that we are connected to this database here. But maybe we can connect to the other database. So we'll do \C and then just say tasks. And so this one needs a password. Okay. We'll go back over to here. Good thing I kept my stuff over here. We'll paste and hit enter. So now we're on the task database. I'm just copying and pasting that password each time. So if we wanted to, let's say, create a table in here, I'm just going to go to Claude here and just say, like, create me SQL to create a tasks table and 3 records for Postgres. We'll go ahead and do that. We'll just get some quick SQL here so we don't have to write it. There we go. I don't know if we need indexes and all that other stuff, but I guess we'll go ahead and just paste it in. I'm not sure if it'll take all of them in one go, but we'll find out here in just a moment. Okay, you obviously have to find this stuff yourself. So now let's say describe. So now we have a task table. We say select all from tasks. And so we can see inside of it. I would like to externally connect, but there's obviously some other thing going on here that's going to allow us permissions. I want to go take a look at our firewall rules. I'm not sure if firewall rules apply here to our VPCs, or sorry, our SQL databases. So I don't see anything open here. So let's go back over to SQL Cloud. And let's just take a look at our networking settings, because maybe something had to be open. So what I'm looking for here is something to do with networking. You can also read the docs here if we want to find another way to connect. And whoop, I didn't even know about this. Log into your database. Oh, wow. Okay. Well, that would be fun. Built-in database. Sure, let's try this. This is wasn't what I was looking for, but it looks like this is an easier interface to interact with it. I don't think I've actually ever used this before. Oh, cool. There we go. Well, why were we doing it the hard way when we could just access our database this way the entire time? Gemini Code Assist can help us write code. That sounds fun. So here I could say like, create 20 more records for me to insert into the tasks table. And we'll generate that out. Cool. SQL is a query language and not a data generation tool. Well, yeah, you can. That's not very useful. Okay, but sure you can. Create me. So that's kind of annoying. Let's go here and just like, can you create me 20 records of data, not in SQL, just in text. Let's go ahead and see that. Because what I want to see is if that tool will actually write it for us. Okay, I don't know if I can take all of it, so I'll just take the first 4. And we'll go back over to here. And we'll say, turn this into inserts for tasks. Can it do this? I mean, it definitely did that. So fix login page to resolve. We'll go back over to here. See if any of that maps up. It does, so we'll go ahead and try that and run it. There we go. So we just inserted. That's cool. And I mean, all that really is just an editor. I'm not sure if they have a preview mode. That'd be really, really nice. I don't think it does. Maybe we can go here. Let's see. No, but it'd be nice to be able to see the data, right? So like here we can go in and we can see that structure. At least I don't know how to do it. So that's totally fine. But anyway, my goal really was how do we externally connect to it? Because if we're working with an application, you're going to need to know how to do that, right? Now, maybe this is less of an issue. Maybe when you're on the internal network, it's easier. But the idea that it has a public-facing IP address made me think that it would be able to handle that there. So just give me a second, okay? All right, for those who don't know, I've actually recorded this before in the Digital Cloud Leader. So it shows it's been a little while since I've done it. And so it looks like the way I did it last time is I went and I edited it because there were settings under the network. This interface is a little bit different, but under security, there was a way to authorize networks. Maybe it was under connections here. So it says, you can specify a CIDR range to allow IP addresses in those ranges to access it. And so what I'm doing here is I'm adding a network, and I just say my home network. Or here we could say from anywhere. So I could say 0.0.0.0/32. That's obviously not what you want to do. You probably look up your own IP address, and we could do that. Say, what's my IP address? Here. And waiting for the IPv4. There we go. So I'm going to grab this IPv4 address. We'll go back over to here. And I'll just do this and say /32. It wouldn't be 0.0.0/32. That makes no sense. To be 0.0.0/0 for everyone. For everywhere, we'll say my home network. And so this will allow us to establish that connection. And we'll go ahead and save that. And then we'll go and try Table Plus again once it's updating. Notice that we have this symbol here. So it can look like it's ready, but it's not. And so if you go to connections here, it's showing you that it's still updating. So we'll wait for that to finish updating, okay? All right, our server is updated. And so now we've added that to the network. We're going to go back over to Table Plus. And I think we already have most of our connection information in there. And now we're able to connect instantly, no problem there. So yeah, it's interesting. The last time I did it, exact same problem, forgot that setting. But yeah, there you go. So we are done here. So we'll go ahead and tear down tear down the server. Okay, and we'll say my PostgreSQL server. I don't need a backup. We'll go ahead and delete that. And I'll see you in the next one, okay? Ciao. Let's take a look at Spanner. So Cloud Spanner is a fully managed relational database service that is both strongly consistent and horizontally scalable. Its key features is that it ensures data is instantly replicated across all regions using Google's atomic clock system called TrueTime. Supports globally consistent reads and distributed transactions across regions, automatically manages replication, sharding, and performance optimizations based on data size and load, provides synchronous data replication across independent zones or fault tolerance. When I first used Spanner, there was only one flavor of SQL. It was some SQL, like Google's own SQL flavor. Now they have Postgres support or Postgres compatible support, which seems very similar to AlloyDB, except AlloyDB literally works perfectly with Postgres, whereas this one's Postgres-esque, but doesn't always work as expected. So I was very frustrated using Postgres utilizing with Spanner. But again, Spanner is what it is. It's pretty good. Let's take a look at its architecture. So data is in a regional instance. It is distributed across multiple zones for fault tolerance. For each zone has compute nodes for query processing and data management. Compute handles queries, ensures strong consistency using Google's TrueTime, stores data in a distributed way and durable way replicated across zones. Spanner synchronously replicates data across zones while automatically scaling compute and storage based on demand. Okay. Hey, this is Andrew. In this video, we're going to take a look at Spanner. Spanner is a relational database. Well, technically it's NoSQL, but it allows you to use SQL Google flavor or Postgres. And underneath it can do graphing, vector, full text search, but it really depends on what kind of version you start up here. Your screen might look a little bit different. I can't set mine back to the original screen where it says like 90 days to whatever. So it'll look a little bit different, but just proceed to fill in the two items and hit enter next. Here I'm going to choose standard. If you compare the additions, if you are in Enterprise or Enterprise Plus, you're getting additional functionality. I'm trying to keep this cost effective, so we're staying with standard and we're not really using that additional functionality. We'll go here to the next one. I'm going to say my instance, and here this will be, we'll leave it as the same. That's totally fine. I'm choosing regional. I'm going to launch mine here in Toronto. I'm going to go to the next thing here, continue. I'm choosing one node. I'm turning off backups here. And notice the cost is $1 an hour. If you're not comfortable running this, totally just watch here. But it's not a cheap service because it is a fully managed service. So we're going to need to create our database. We have a couple options where we have Postgres and Google SQL. Every time I use Postgres, it doesn't actually work. And then Google SQL is a big pain in the butt. So just understand that this might be a bit of a struggle. We'll probably use Claude to help us write it and work through this here, but we'll do our best that we can here. Let's say we're making a to-do app. I'm going to go over to here to Claude. And before we do that, we'll just actually create our table. So if we go here, we can create a table, right? And I just want a to-do table. So I'll go over here and say, using, what is it called? Google Standard SQL. Create me a table for a to-do app. So so we'll see what it does. And hopefully it just works. That's a lot of data. Okay, it just never seems to listen. Keep it simple. Always overdoes it here, but we'll try to get something really, really easy here. Because we can fill this out, but it'd be a little bit nicer if it just does that. Excellent. I don't know if the timestamp's going to work, but I guess we'll find out as we work through this here. So I'm going to go ahead and copy this and hit enter. And hopefully it just works. And it's having a problem with the timestamp one. So I think it's because it can't handle the timestamp. So we'll go ahead and we'll just remove this one here. Okay, and then we'll just try this. And so we're having some issues here. We'll go back over here. Again, it's really not worth your time to try to learn this unless you're going to do it for real. And I'd rather just kind of fiddle with this until it works. Okay, no created at timestamp. Let's get that out of there. We'll keep it nice and simple. There we go. And we'll try this one more time. But yeah, working with this programmatically is a headache, but you know, it scales and it works really, really well beyond that. So you have to make your trade-off there. Here it says the update failed. That might be just old failures. Let's go over here and see if we have a table. We do. Great. So we'll say, give me inserts now for the data. 10 records. And there is Google Gemini here, but it's notoriously bad. So there's no point in even trying to use it. This is the 6th time I've done this lab. So I'm telling you for certain, I'm not even going to bother trying to use Gemini there to generate it out. It's nice. It's like a nice idea, but if it doesn't work, it doesn't work, right? So we'll go ahead and do this. And so now we have 10 rows inserted. So the question is, how are we going to connect to our database? This is a little bit different because, you know, with SQL, like a Postgres database or something, you establish a connection. With this, we actually have to use the API or SDK. What I'm going to do is go over to GitHub here, and I'm going to see if we can establish a connection. Well, here's the question, is that if we use Spanner, can we connect to something that is, is not within our VPC? Because I feel like, because it's such a robust service, it probably have some restrictions on how we can connect to it. But just give me a moment, okay? So I just found the Spanner client libraries. I really like Ruby, so I probably would utilize that to get it working. The question still is that even if we do get it working, you know, is that going to be enough, right? So if I want to see how this works, I'm going to have to look up this gem because they're not really providing a whole lot of it. Oh, here it is. There's the information. Okay, so require Spanner, project ID, information here, and there's the connection. So that does look really straightforward, but I still don't know if we're going to be able to establish a connection. I just kind of expect something else to go wrong here. But we'll go ahead to our repository that we've been working with, the GCP examples. I believe here I already have one running here. If you don't know how this works, go check our earlier videos in the course. I mentioned them multiple times. So we're going to go ahead and open up. Oops, I don't want this opening in Visual Studio. I opened up the wrong tab here. I meant to open this up in the browser. And so this is going to open up GitHub Codespaces. We will connect to Google using gcloud auth login once this is here. Okay, this is just a moment here. gcloud auth login. gcloud auth login. This is already installed because I have a dev container here. Okay, so if you don't know, watch earlier videos. So here I'm going to hold control and click here to open this up in another tab. And then I'll go ahead and authenticate here. I'm going to assume that we need to do this to connect. So if we need additional permissions, we'll figure it out as we go here. So we can go ahead and paste that in there. And I'm going to go ahead and set the project while I'm here. So we'll go over to here, and I'm going to set this to my GCP playground. And I'll paste that in here like that. There we go. So now our project is set. I'm going to go over here and make a new folder for Spanner. And this is just because we're creating an app. So I'm going to go here and just call it main.rb. Ruby's already installed on here, so it'll make our lives really, really easy. I'm going to initialize a bundler file or a gem file. And that will allow us to import that information. So if we go up to here, we'll take a look and grab that. Just so you know, these instructions that are on here don't always work. So if it doesn't work, that's totally fine. We'll just work around it. But I'm a really good developer, so I think we'll be able to resolve any issues that we have here. If it's networking, then it'll be a bit more of a pain, but if it's development side, it should be fine. So we'll scroll on down back to, this is old stuff here. We'll go down here. I'm going to grab all of this here. I don't think we need to do application default login, but we'll see what happens. I'm going to go ahead and copy this over here, and we're going to paste it in here as such. So here, it's not connecting to a specific, well, it's interesting because I called it my instance. Our database is called to-do, and we probably would want to select all from tasks. We say select all from tasks. And if that works, that'd be really, really nice. We have a project ID already set here, but I guess we'll grab it again. So we'll just grab that value one more time. We're going to go back over to here. I'm just going to hard code it in. If you can, don't try to hard code these values. It's not going to hurt anything, but We have that set up. And so now I want to see if this code works. If it just works, that'd be really, really great. So we have bundle exec Ruby main. And we're going to scroll up here and see what we get. So it says your credentials were not found. So to set up, use application default. So we did have to do that. Okay. So we'll go back over to here. And we will do gcloud auth application default login. So we'll go ahead and paste that in. I'm going to click through here again. Again. Continue. Continue. And we'll copy that. I think if I right click, it'll just put it in there. We'll hit enter. So now it says was added to ADC, which can be used with Google Client Libraries building quota. Excellent. Okay. So now what we'll do is go ahead and run this and see what happens. And hopefully it just works. No, what is our problem? So here, table not found called tasks. Let's go back over there and make sure we even have a table called that. So we'll just click out of here. We go to Spanner. Oh, our table's called to-dos. Well, then what's our database called? Is our table called to-dos and our table's called to-dos as well? Oh, it is. Okay, that's fine. It's not a big deal. I thought it was called tasks. So we'll go here. First of all, the database is called to-dos. And I think, well, hold on. We'll go back one more time and check. To-dos. Yep, to-dos, to-dos. Okay, fine. I apologize for that mistake. Okay, so we'll go, whoops, that's not it. We'll go do this, and we'll try this again. We have a new error. Now what is our problem? Database not found. So instances, my instance, etc. Let's go back and take a look to our overview. Our database is called to-dos. Our instance is called my instance. Oh, the database name is to-do. Okay, so the table is to-dos and the database is to-do. That's so darn confusing. That's my fault though, of course. We'll go ahead and try this one more time. And there we go. So now we're able to interact with our Spanner database. So there's more to Spanner, of course, but that's the easiest way to get started with it. I'm going to go spin down this instance, and if we need to do more with it, of course, we will just make a new instance, okay? So we'll click into here, and we will delete this instance. Good. I'll go ahead and commit this code. And I'll see you in the next one. Ciao. Hey, it's Andrew Brown. In this video, we're going to take a look at Firestore, not to be confused with Firebase. So Firestore is a MongoDB compatible database, and I don't know, it's really good for real-time stuff. I know that for certain. Let's go ahead and create ourselves a new Firestore database. And so we have standard or enterprise edition. Of course, we want to keep things cost effective, so we're going to stick with standard edition. It says database ID is default here, and it's a permanent choice. I guess I don't care, but I probably want to change that. So we'll just call this to-dos. And then down below we have Firestore native or Firestore with data store compatibility. Today I just want to use Firestore native, which seems fine. Enables Firestore native server-side web and SDK. That sounds good to me. Allow anyone to view, edit, delete all data for the next 30 days. Deny all reads and writes by default. These rules apply for access controls. It sounds like restrictive is better. I mean, open sounds really easy and fun, but we'll stick with restrictive for now. And I don't need multi-region, so we'll just do a region, and we'll launch this in North America, Toronto. We'll go ahead and create the database. And we'll give that a moment to create, okay? All right, so what we're going to do is go ahead and create a collection. This is pretty standard for MongoDB, right? So here we're calling it tasks, and we can insert our first document. And I don't know where that came from. I guess it's just auto-assigned, assigned automatically. Hold on here. We'll try that again. Yeah, do we add another one? Does it just automatically do that? Okay, sure, why not? And so I'm going to have our name. It'll be like, create Firestore database. and we'll have completed. Do we have a Boolean? We do. And I'll just set this to false. We'll go ahead and save that. And so now we have our first record. We'll go ahead and add another one. And again, it's just autofilling it. So this will be our next task. Because it's MongoDB or MongoDB-like, the idea is you can add as many fields as you want, and they don't have to be the same, right? So here, this will be completed again. Right, this will be populating database, populating documents into table. Maybe we'll set that as true. And down below here, we could add another one and say amount. And we're just being abstract about these values, right? Because they're documents. So now we have some data inserted here, and we're going to want to actually interact with this database, right? So I'm going to imagine, we do have a query builder as well, which is nice over here, but I'm going to imagine that we're going to probably use an SDK for that. So we'll go look up Firestore SDK, and we'll see what we have here. So there's like web, iOS, Android, Flutter. I want to do this server side. I don't want to do this via mobile applications. And so we have the SDKs here. We'll take a look here. They call them admin SDKs. I wish they had Ruby. I don't know why they have everything else, but they don't have Ruby. But I guess it depends on what you're doing. So these ones here, well, this is for Firebase, right? So let's say Google Cloud Firestore SDKs. Not Firebase, Firestore. Like technically Firestore is within Firebase. I just want to make sure I don't get confused there. And choose the wrong one. Do they have one for Ruby? Maybe there's a third-party one. I don't know. Apparently they do. So Cloud Firestore is a NoSQL document database built automatically scaling. I keep using Ruby because A, it's my favorite language, and B, it's really easy to use and learn. So it seems like there is one. But you can see sometimes documentation is a little bit hard to find stuff. So here it says Cloud Store, document database. I just don't know what gem to install. So we'll go ahead and I'll go use Cloud as a search. What gem am I installing to use this? Okay, maybe it is that. That'd be really nice if it is. We'll make our way over to GitHub here. And as per usual, we'll go over here and to our GCP examples. I've showed this many times, and I actually still have it running here, but I have a code spaces, so use whatever you want. I show you how to set this up earlier in the course. If you were skipping videos ahead of time, go back and find those videos. I repeat it multiple times over and over again. We'll go ahead and make a new folder here. This will be for Firestore. So we are here. I'm just going to make a new one here. This would be like basic Ruby. And we will cd our way into there. So I'm going to make a new gem file. So we'll say bundle init. And that will create us a new gem file. From here, we'll go back over to here, and we're going to grab this. And so now we have that there. We'll do a bundle install, and we'll see if that actually works. It looks like it is, so that's good. I'm going to make a main.rb here. And let's go take a look at the code that they've provided. This code might not work. Sometimes the docs are just wrong, but that's fine. If it is, we'll work our way through it, okay? So we'll go ahead and paste this here. So here we're creating a new Firestore instance, get a document reference. So I feel like there's more to configure than that, right? That's not going to make any sense. So what I'm looking for here is I'm trying to figure like, okay, how do we establish our connection, right? So in general, Cloud Store, library, service account, credentials to the Google Cloud account. Okay, and so there's some environment variables. We have the project. But again, that's not what I'm looking for. I'm looking for, how does it know what what database to use, right? Because we're not seeing that option. So I'm going to go over here and say, all right, now how do I connect to a specific a database for Firestore using this API. Let's see if this can find it for me. But I like to find things in the docs directly, but you can see that there's a lack of documentation. So here we're seeing project ID, database ID. That could be it. I'm not really certain if that's true or not. And it is bringing that credentials file in. I'm not sure if we need that either. But we'll go ahead and we'll copy this over and we'll see if we can work through this. I'm very hesitant with code that comes from LLMs. They don't always work properly. But we'll go ahead and do our best. So here I'm going to drop this down. We'll grab this ID over here. And we will paste it in here like that. The database is called to-dos. And all I want to do is just kind of like read out the contents of them. So I'm not worried about credential files yet. How can I print out all documents in a collection? There we go. So we will see if that works. And we'll go ahead and paste that in like that. Let's go take a look at what our collection was called. I already forgot what it was called, so we'll have to go check. It's called tasks. So we'll go over to here and we'll change this to tasks. Okay, and that looks pretty good. I don't know if we have to do any establishing connections. I didn't have this up. I had already had this up, so this might already be connected, but I did gcloud auth, login auth. And then I also did like application default or gcloud auth login. But I'll run through this again just in case. Right? But I'm already logged in, but I'll just do it again. We'll copy this one here. Okay. And I'm already set for this project. If you're not, you can set it manually, but we are setting it here as well, so it's less of an issue. I also did, but this was for when we were doing, I think, Spanner. I did this. I don't know if we actually need to do it for this, but I kind of feel like we do. So I'm going to do it anyway. If that doesn't work, we'll figure it out. Okay. And let's go ahead and see if this works. So I'm going to go ahead and run this. I'll do bundle exec Ruby main. That's just how you run it in the context of that. And it'll work or it won't work. And so here we have it. It worked. So as simple as that. We didn't have to do anything special. I do think we probably had to do that application default for it to work. But there you go. We've integrated Firestore. There is a lot of cool features with Firestore, especially with streaming. But it is there, you know, if you want to use Firestore. I'm going to go ahead and delete this database because we are now done. There you go. I'll see you in the next one. Ciao. AlloyDB is a fully managed Postgres compatible database service built for high performance and scalability in demanding applications. A single AlloyDB deployment in Google Cloud region organizes resources into a cluster. A cluster consists of nodes, so these are virtual machines running the Postgres engine, grouped into instances with private static IPs. Apps connect to the instance using Postgres protocols, which forward SQL queries to nodes. AlloyDB has two kinds of instances: a primary instance, which we will say, which could be either a high availability primary, which includes two nodes, an active and a standby, which with automatic failover ensuring high availability, and then basic instance, a single node for non-production use with no standby. Again, just depends on you know, if you're just trying it out or if you're you know, utilizing this for production use case, right? There's also a read pool instance. So this is an optional read-only instance up to 20 nodes per cluster with automatic load balancing. So let's take a look at this diagram, which shows a bit about how these things are connected. I mean, it's pretty straightforward, but the idea here is that you have your primary instance, and then here we have our read pool, and then down below we have a storage layer, which is shared, which is going to give us consistent and durable data across the cluster. Okay, let's take a look at some of the key features. So it's 4 times faster transactions and 100 times faster analytics than Postgres. Lightning fast, let's call it scan powered queries for Vertex AI, 100 times faster insights with Columnar Engine, natural language SQL with smart recommendations. Its use cases here would be fast response times for e-commerce, finance, and gaming, simplified Postgres migration, Real-time BI, so business intelligence, fraud detection, AI-driven vector search. For pricing, that's its cost per vCPU. For memory, that's its cost. For storage, that's its cost. For networking, you have free intra-region data transfer there. So hopefully that gives you an idea. But the key thing to remember is AlloyDB is basically like enterprise. If you've ever used AWS Aurora, that's kind of the equivalent over here for AlloyDB. But yeah, it's very, very much Postgres or Postgres compatible, which is really, really nice. Okay. Hey, this is Andrew. In this video, let's take a look at AlloyDB. So AlloyDB is a fully managed enterprise-grade Postgres instance, which I love Postgres, but if we can use one that is cost-effective, that would be good. Here we have a sandbox-free cluster, a free environment to experience AlloyDB's superior performance. That sounds really nice. Over here, we can see starting $14 a day. Wow, what a great price. If you are not comfortable with these costs, that's totally understandable. You don't have to do that. I'm going to try the free trial. And we'll create new. We'll see what we can actually do in the trial. I'm not sure what limits there are on it. We'll go ahead and do that. And it looks like it's actually spinning up a development cluster. So we'll call this my Alloy. Why not? Or my cluster. We'll call it my cluster. And here we'll generate out a password. I'm going to show it. I'm going to copy it. I'm going to place it in another tab. And I hope I do not lose it. So here we only have up to 16. I think 17's out. So at least at this time. So that's one thing. Over here on the right-hand side, we can see the costs. Again, we're just trying to get this up, make sure we connect to it, and experience a basic database. We're looking here for Toronto, so here we go. And here we have private IP connectivity, enable private IPs, always enable. Public IPs, yes, please. And we actually have to add or authorize network. So very similar to Cloud SQL. So let's say, what's my IP? We'll go here. We'll wait just a moment. We're going to grab that IP address here. Give it, yeah, there it is. So we'll grab that, go back over to here. We'll drop this in, and we'll put a /32. We'll scroll on down, and we can see we have N2, 64, whatever. Sounds great. I mean, normally this would probably be really expensive. But again, I don't want to keep it up for very long. So we'll go ahead and start a free trial. And so that's going to spin up, and we're going to wait for that to be provisioned, okay? And while this is provisioning, it's telling us some things we might want to do. So it says create a cloud storage bucket in the project where your Alloy database is located. Upload the SQL file in the storage bucket. Okay, so I mean, we can do that. Click the import data to navigate to the import form. Provide the GCS path to the SQL file. Okay, so yeah, I'm going to go ahead here, and I suppose we can create a new bucket to get prepared here. I thought it'd be a little bit easier than that, but we'll see. So we'll go ahead here, and we'll make our ways over to buckets. And this will just be I still have that migrate bucket. You know what? I'll just use migrate bucket. You can use whatever you want. This is the bucket that I have kicking around here. And I'm going to go ahead and just say, like, I need an import script for AlloyDB. Create me one. Okay, so we'll go over to here. I'm not sure if it'll do a good job here, but prepare the SQL file for the bucket. Let's go see if there's any particulars that we have to consider. And so we have CSV, DMB, and SQL file. I think SQL sounds a bit better. So I'm looking here. Let me just see what we need to do, okay? So it doesn't really tell us much about the format of it, so that's a little bit confusing. I don't really care if we use those import operations, but let's just pretend that we did. Navigate the import data and import with the GCP, create the database. Okay. If we go back to the step, it's up here. So we'll just keep waiting here, and I guess what we can do, I just need SQL. Like, what is it doing here? Okay, you're not listening. Only Postgres. Holy smokes. There we go. No, 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 no. Only write SQL. We are creating an SQL file with mock data. Okay? I don't know what it's doing here today. There we go. Okay. The only thing I don't know is like, can we set up tables? And like, it doesn't tell us that, right? There's obviously the import statements. We say like AlloyDB, try not to lose that. AlloyDB SQL import example. Like it tells us we should import one, but it doesn't tell us how, which is kind of annoying. A CSV file could work as well. If you're migrating an entire database, etc., before you begin doing so, prevent issues. It doesn't talk about like the table rows or anything like that. So how would it? Yeah, a table already has to exist. So I would think that you'd have to create the table, and then it would just be import statements, right? So let's go back over to here. Is it still creating? It's still creating, right? So there's not a whole lot that we can do until it's ready. I mean, if we can connect to the database this way, I don't see why that even matters because we can just query there. But we can try the import statement, but we'll see what happens, okay? We're just going to hang tight. All right, so our instance is ready. Let's go over into the AlloyDB Studio, which is just like Spanner Studio or the SQL one, apparently. And we're going to go use Postgres, and we kept that password around. Please, please, please. There it is. Let's not lose that tab. And we'll go ahead and authenticate, okay? So we're going to authenticate. This is just a Postgres database, so I assume Postgres queries are going to work here. And I think that mass import thing is really if you have an SQL file that's really, really, really large, or there's obviously another way to migrate it. We'll go ahead and open up a new SQL tab. I want to create this table, so we'll go all the way to the top here. And I mean, I guess we could just take these here. I don't care. Let's go grab all of this and see if it goes. So we'll go ahead and paste it in here. We'll hit run, and hopefully those tables just create. Excellent. So we have those tables. So this is definitely Postgres. Whereas with Spanner, even when I didn't do it in the video because I had so much trouble in the Postgres compatible mode, but like it couldn't handle timestamps and other things, so it wasn't truly. I might use the Postgres syntax, but we couldn't use all the features of Postgres, which was frustrating. So now we have those tables. We could import the data here, but you know, why not use that import thing? Because they made a big stink about like, hey, you can use it. So if we click on this import, here it wants to be in a bucket. We have SQL, a plain text file with a sequence of SQL commands, like the output of a PG dump. I don't know if this is an output of a PG dump. I mean, probably it looks similar, but it's probably just going to run this sequentially, right? So I'm just going to grab all of this here. Not everything, but I'll grab this stuff here. And let's just try to make an SQL file. So I need to just make a file really quickly on my local machine. Okay. I'm just trying to do that off screen here. I'm not sure my clicking is, there we go. My clicking wasn't working. So we have that there. We'll go ahead and save that as a file to my desktop. And then this will just be import.sql. Now that I have that, we'll make our way over to a bucket that I have. So we have this bucket. I'm going to drag on over. Once I open up a file explorer window here, I'm going to drag on over that import SQL here. I'm going to drop it plainly in here. Okay, the question is, will it have access to this bucket? I would hope that it could, but I don't know if we have to do some special permissions here. I do not see, oh, there it is. We'll click into it. And I need to get its GS link here. Here it is. So we'll grab that one. I believe that's what it wants. So we'll go back over to here. I'm trying not to lose this tab here. And, oh, we can just browse. Well, that's even better. Let's do that. Migrate bucket, import. There we go. Select. If this doesn't work, I don't care. But if it does, that's great too. How would it know what table to insert into? I guess it's in there where it says to insert because it's the same table, right? We'll go ahead and run that and see if it works. Again, we don't have to do it this way, but because they have it there, we should try it. So it's finished. Let's just confirm that the data is there. So we'll go over into categories. I guess we just have to search any of it. So we'll say select all from orders. We'll run that. There's our data down below. So definitely inserted I'm going to assume that there is a, well, if this is a Postgres database, this would just have a address, right? Because I don't think we'd use an SDK to connect with this. So where's the connection information? Connectivity. Okay, so it looks a lot like how we would normally connect with a database. Let's bring up Table Plus. I'm going to delete this one. We don't need that anymore. We'll go ahead and create a new connection in here. We installed this in the Cloud SQL, so didn't watch that one. Go watch that one first about installing Table Plus. And so I want to grab some information here. I'm just going to drag that half off screen so I can click back onto it easily. So what do we need? We need the host. So the host is the public IP address, right? And we'll paste that in. The user, I believe, is Postgres. The database is Postgres. Our password is precariously living on that tab, that new tab there. And I'll go back to here and we'll paste in our password. I think that's everything. And this will be like AlloyDB. I'm going to test. Unknown driver error. Let's make sure we put in a port here. Test again. Unknown driver error. This does not look right. Let's do that. Test that again. Connection's okay. We'll save it. Let's go here. Make sure that we can see stuff. We got lots of stuff. We'll go here. Our data. So we have our data. There we go. Great. So yeah, not too hard. Actually, I really like that. That was not too bad. So let's go ahead and get rid of this really, really expensive cluster. But you know, if you're an enterprise and you like Postgres and you just want it to work, I could see why they made this, because Spanner, I'm sure, is good, but if you really like Postgres at scale, then this is even better, right? So now it's deleting the cluster, and we'll just wait for that to go. There's probably more things we could do with AlloyDB, but that's a simple introduction. So there you go. Bigtable is a fully managed, scalable NoSQL database for real-time analytics on massive data sets. It handles petabytes of data with horizontal scaling, provides low latency, high throughput for real-time analytics. It's ideal for large, sparse data sets with wide column NoSQL structures, partitions data effectively across nodes for scalability, integrates seamlessly with Google Cloud Services and the Hadoop ecosystem. The use cases here would be time series data, marketing data, financial data, IoT data, graph data. In terms of its architecture, clients' requests are routed through a front-end server to a big node cluster, and each node manages specific requests and handles tablets, which are shards of Bigtable tables stored in SS table format on Colossus. Adding nodes increases capacity and throughput to handle more requests. Tablets can move between nodes without copying data, as nodes store only metadata. Writes are stored in Colossus for durability. No data is stored directly on nodes. So there. All right, so let's talk about managed file storage. There are no pretty graphics for this one. It's all just text here, but let's make sure we understand what it is. It's an alternative to compute engine disk persistent block storage. And so there are many managed solutions that Google is either partnered with or provide, I think, directly for more volume options, okay, or disk management options. So we have Firestore Basic, Firestore Zonal, Firestore Regional, Google Cloud NetApp Volumes, Google Cloud Managed Lustre for partners. So these managed solutions, I believe, are managed by Google, right? So if you ever heard of NetApp, that would be a means to which you'd get NetApp, and one of the easiest ways there. Let's take a look at partnered solutions. So you can directly work with NetApp and use ONTAP, Nasuni, Cloud File Storage, Syscomp Storage fueled by IBM. And so when would you want to use these solutions? When you have lots of storage and you want Google or a partner handling all the storage operations. It provides additional flexibility for storage features and configuration. If you're not really into storage, you might think, okay, I don't really understand, but there's a lot of functionality that you can tweak when you are utilizing these things that go well beyond compute engine disk persistent block storage, okay? BigQuery is a serverless, fully managed data warehouse and analytics engine designed for fast, scalable data processing across clouds. So here is a screenshot of the BigQuery Studio, and I'm just going to tell you that this is the best-in-class data warehouse out of all the cloud service providers. If there's one service really worth using on GCP, it is BigQuery. And so the idea here is that you can run SQL queries in your editor. It's pretty straightforward to use. You can easily connect to various data sources and BI tools for smooth data import. You can quickly browse data sets and tables through the user-friendly interface. You can use the UI, command line, APIs, making it simple for both beginners and experts. In terms of the workflow, it kind of looks like this. So on the left-hand side, you have data ingestion. So you have things coming from BigQuery, cloud storage, Google Sheets, databases, apps, files upload. You're bringing that raw data into BigQuery. It's interesting. You can bring BigQuery into BigQuery. And here we can refine the data, and then we can output it to BigQuery or cloud storage. And then from there, we can analyze the data with BigQuery or BigQuery ML, Looker, which is obviously a BI tool, Google Data Studio, partnered BI services like QLink, or send it to the Cloud AI platform. In terms of key features for BigQuery, we have serverless and managed. There's no need for infrastructure. Google handles scaling and updates. And I'm going to tell you, there's other providers that have serverless, I'm doing air quotes right now, serverless data warehouses, but the only one that I consider truly serverless is BigQuery because it's so easy to use. It's real-time and flexible. It supports continuous data streaming and handles structured and unstructured data. It has multi-cloud analytics, so it can analyze data across multiple clouds using open formats like Apache Iceberg, which is becoming a very popular table format. We have efficient storage and querying, so columnar storage for fast queries with built-in analytics and machine learning. Security and governance, so centralized access controls, encryption, and compliance tools. It has flexible pricing, so on-demand or reserved pricing to optimize costs. And when we're talking about data import, it can support a variety of format types, so CSV, JSON, Avro, Parquet, Google Sheets for analysis. But Excel is not supported, which kind of makes sense. It's a Google product. And if you ever tried to parse an XLS file, it is a pain. So I kind of understand that. But a really, really good service. It is worth your time to learn more about it, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at Firebase. So this is Google's fully managed platform for rapidly developing and deploying web and mobile apps. Really, it's a platform as a service utilizing serverless technology. Firebase offers the following services and features. So Cloud Firestore, machine learning, cloud functions, authentication, hosting, cloud storage, real-time database, crash of Linux, performance monitoring, test lab, app distribution, Google Analytics, in-app messaging, predictions, A/B testing, cloud messaging, remote config, dynamic links. So Firebase is basically an alternative to using Google Cloud directly for users who want to focus on building and deploying their applications in a highly opinionated framework. If you ever heard of AWS Amplify, that's the AWS competitor for this. The only thing that I find, like, this service is great, but I find that it's very hard to migrate off of Firebase onto Google Cloud. But the idea is that, if you don't really want to learn all the infrastructure as a service stuff and you just want all this convenience around you, this thing is really great, okay? Hey, this is Andrew. In this video, we're going to look at PubSub. So in the top here, we'll type in PubSub and we will find the PubSub product. So it is over here. We'll go ahead and create ourselves a new topic. And we'll just say, my topic, be whatever you want it to be called. We could add a default subscription. We don't need to enforce a schema, but it's not a bad idea to enforce a schema. Do we want to enable streaming data? No, I don't think so. That doesn't really matter. We have enable message retention and a bunch of other options. But for now, I think it's fine if we just have that there. We'll go ahead and hit create. And we'll give that just a moment here. And so now we have our topic and subscription. So probably what I would like to do is I would like it to do something. And so what we probably need to do, so here we have a subscription and topic. I want to push something to our queue. So what I'm going to do here is look up SDK PubSub Google Cloud, and we'll see if we can find something here. As you're finding with a lot of these libraries, we pragmatically work with them, and they usually have client libraries. I'm assuming they have a Ruby one. They seem to have Ruby for everything else, and if they do, I'm going to use Ruby because I like Ruby. And they have one, so here it is, Google Cloud PubSub. So I'm going to make my way over to GitHub, and we are going to go here and pull up GCP examples. And I'm going to close this out because, no, you know what? I'm just going to use it. It's totally fine. I'm going to open this in the browser. And so I've been using the same code space again and again and again. If you want to utilize this stuff, you're going to have to log in. So probably we'll have to do, auth application login, which is fine. I set this up much earlier in the course, so if you want to use GitHub Codespaces, you can. If you don't, you can set up your local machine. This one has Terraform and Google Cloud CLI installed. All we need is a CLI. Watch earlier videos for that. I'm going to just clear this out. And I was, I think, attempting here before Bigtable. That didn't work out, but that'll be another video you will see later on. So what we'll do is go to the top directory here. We're going to make sure that we log in with application default login. So go ahead and hit enter. We're going to have that link. I'm going to hold control, click on the open. We'll go here, connect. Okay, we'll give it a moment here. Continue. We'll copy this code. We'll go back over to here. We'll hit enter. And so now we should be authenticated. My project's already set here to GCP Playground 1212. You might want to set that default yourself. Usually they will tell you here how to set a default, but it's up to you. So anyway, what I'm going to do here now is I'm going to make a new folder. This will be for PubSub. And we'll make another folder here. This will be like basic Ruby. And I'm going to cd into that directory. I'm going to initialize a Ruby file. The reason I use Ruby, it's my favorite language, and it's super easy to use, and the code's easy to read. So multiple reasons, but generally these are all basically the same. Like language-wise, but I'm going to use the language that is easiest to use. So we'll go ahead and we'll do a bundle install. So that's going to install that there. We'll go over to here. We'll scroll on down. And here we have a very basic example, which looks good to me. We'll have to create a new file here called main.rb. We'll paste in this contents. And so we need to provide our topic ID. I think we call it my topic. And this is for creating a topic. We don't need to create a topic. We already have one, right? But we could create it via the SDK here, which is fine. So what I'm looking for here is how would we go about pushing something to it. So we'll go down to the Ruby reference library and we'll scroll on down. So here we have an example and we can publish an article or a message to the pub sub here. So publish a new message, retrieve a subscription, right? So here we can do this. I'm just reading through it. Create a subscription to listen for available messages. By default, this will block. So you might want one that publishes and one that listens. So what I'm going to do is I'm just going to change this over here so we have publish. And we'll just do this a bit separately, okay? So we'll take that out. We don't need that. And just in case it wants us to set the project ID, it most likely will want us to do that. So I'm just going to get ahead here and do that. I know that I already have one here in Firestore, so I'll copy that over. Obviously yours is going to be different from mine. And so that will get us set up there. And so this should publish a message. I can just do a puts here and see what happens. We'll type in clear, and we'll do bundle exec Ruby publish. All right, and so it has a problem with topic here. Let's go back over to here. Pubsub.topic, right? So we'll go back up like this. And we'll hit enter. And so that is now published there. Let's see if we can see any information from the UI. We might not be able to. It doesn't really matter though. And we can do pull from here maybe. Oh, it's showing whether someone's pulled or not. Sometimes, like at least with AWS and other providers, they give you an interface in order to see those there. I wonder if replay messages will let us do that. There are no snapshots of acknowledged messages. That's fine. Okay. And that's totally fine. I like this PubSub Lite. I actually don't know what that is. I might have to go and explore that separately. Oh, you have to enable that. Okay. But what I'm going to do here is, I guess, just listen. We'll do that there. So I'll go ahead and make a new file here. We'll call it listen. And I'm going to go over to here. And so we need something that is similar with the code. So I'll go back over to this and we'll grab this to start with. right? And we'll go over to here. Do we have our description? We have our topic. But we're going to need our subscription here. Let's go take a look at what our subscription is called. So we go to subscriptions, my topic sub. Okay, is it already called that? It is, nice. Lazy naming makes it easy for us. So here, create a subscriber to listen. So we'll go ahead and copy this code. We'll probably need an exception handler. That's a good idea. Gracefully shut down. Start background thread that we'll call and sleep. Okay. So what we'll do is we'll go ahead and paste all this stuff in here. So I imagine what we need to do is run this in the background. So we'll probably need two tabs here. And one will listen and one will receive, right? So we'll go here. And I'm going to go ahead and we have listen. So this is, assuming all the code's fine, it should now be listening. Oh, there we got that message, but it's still probably listening. So if we go over to here and we do, maybe we can split this here. There's a way to do that like this. Not exactly what I wanted. We'll bring this over here and it's not doing exactly what I want, but that's fine. We'll go back over to, well, let's just stop that here. So I'll go on one side here. This will be listen, bundle exec Ruby listen. And then on this side, it'll be bundle exec Ruby publish. Okay, so you see what's happening here? One listens, one publishes, one receives. Okay, so we've now just set up pub sub. It's that simple. There's more to it, obviously, but that's the most basic thing. I think maybe setting up a schema might be interesting. Okay, so apparently here, yeah, you can enforce a schema. So I don't even think I care about doing that right now, but at least we know that that's possible. We have the most basic hello world. If we want to do another one, I'll do that in a separate video. We'll just say pub sub here. And we'll call that done. I'm going to go ahead and delete out our topic here. I think I saved that here. Yep. And I'll see you in the next one. Okay. Ciao. So I just want to make clear the difference between log buckets and cloud buckets because while I was going through one of the courses, I completely forgot what they were. And so I just thought, let's make sure we have a distinctive slide because sometimes there's exam questions that will ask you, where do you want to store it? A log bucket or a cloud bucket? So let's talk about log buckets. So log buckets in your account, you get two by default. You have one called default and required. One can't be disabled. The other one can be. Log buckets are part of the is part of the logging service, the cloud logging service. So under there's like storage accounts or something called storage, and that's where log buckets will reside. The thing is that the logs that you see in your account are always going to a log bucket, right? So that's why I have up here, if I just get my pen tool out, I have logs saying like, hey, it's going here, or it can go here. I know it looks like it goes in this order, but technically the logs can go either here, or you can customize and send it to a custom bucket. But the point is that anytime you are in Log Explorer, you're looking at the default logs, right? That's what you're looking at in the log bucket, okay? And so here you have sub-second query speed, you have built-in log queries, you have real-time access, automatically compressed, configuration retention. But the key difference here is that it's more expensive. And I didn't put in the numbers here because it might change, but it might be like 0.050 versus 0.20 cents, right? So like cloud buckets are a factor cheaper of at least half the savings, right? But anyway, let's take a look at cloud buckets here. So cloud buckets require full scans to query. It has no indexing. It has indefinite retention. It updates in batches. It has no automatic compression. It's more cost effective than log buckets. So that's the key thing. Log buckets can be upgraded to use log analytics to run SQL queries on your log data. So there's just a lot you can do with log buckets. So if you need things indefinitely, you need them cheap, you need to hold them for a long time, you need to maybe put a lifecycle rule on it so you can put retention for long-term storage, then like into cold line, so it's cheap, then cloud buckets. But for the most part, you want to use log buckets when you can, if it makes sense. So, hey, this is Andrew Brown. In this video, we're going to set up ourselves something in Dataflow. So we can create jobs, but I think we need a pipeline before we go ahead and do that. So I'm going to go ahead and enable data pipeline so that we can work with Dataflow. And we'll get that activated here in just a moment. There we go. We'll go ahead and get started. And we'll just give it a moment here to load. There we are. And so now we can set up a data pipeline. So data pipelines are managed end-to-end transformations using Dataflow and Apache Beam. So that sounds really good to me. Let's go ahead and create ourselves a data pipeline. So we'll say my data pipeline. And the reason we want to get experience with this is just like if you ever take any of the professional certifications, if you've at least gone through and used Dataflow, you'll have a general sense of what its applications could be. And that's why we're looking at it. I'm specifically looking for Toronto, if it's even available. Looks like there are some regions which are just not there. So Montreal is going to be the closest one I have here. And then down below, we have a Dataflow template. So there are some that we can get started with. I mean, for the most part, I'm mostly interested in getting data into BigQuery. I mean, there's obviously some other ones here, but we have process data continuously, which is not a bad idea. Is that the major category here for the rest? Process data in bulk, no. Spanner to BigQuery, and a few other ones. So let's go all the way to the top here. And so I want to make BigQuery one of our end destinations here. And so I'm just kind of looking here and seeing where we could go here. So maybe cloud storage to text, BigQuery might be what I'm interested in. Let me just see what else there is. So text files on cloud storage to BigQuery pipeline is a streaming pipeline that allows you to stream text files in your cloud storage, transform them using JavaScript user-defined functions, and then provide and append them to BigQuery. So the pipeline runs indefinitely and needs to be terminated manually. So that sounds good to me. I'm just going to make note of this here for slides. I'll be back in just a moment. All right, so that seems fine to me. We're going to need a source and then a target that we're going to need here. So what I'm going to do is go over to Google Cloud. I might already have a bucket. And if I do, I'll probably just delete an older one and then make a new one here. We'll go over to here. And I think it's time to get rid of the migrate bucket. So I'm going to delete this bucket. This is just me cleaning up old stuff. I'm going to create myself a new bucket. I'm going to make this in Montreal just because the pipeline's in Montreal. I just want to make sure everything works as expected, but it probably will work either way. So just say my data set, pipeline. Okay, we'll go ahead and hit continue. Yeah, I guess it's fine. We'll leave it multi-region. We'll go ahead and hit continue. We'll leave it alone here, and the rest is fine. So we'll go ahead and create that, and we'll confirm. Looks like it needs probably the GS address. We'll give this a refresh here. There it is. And of the text you'd like to process. Hold on here just a second. So here it's expecting there to be text already. So the text files on cloud storage pipelines in the streaming pipeline that allow them to be transformed. Okay. But it seems like we need a very specific format for this. Let me just take a second here to look at this, okay? So here we have, I just looked up here like an example of here, and it's almost like it's expecting it to process JSON. So if that's the case, and apparently there's a Python variant as well, maybe what we'll do is generate some data. So, you know, I am testing Google Dataflow. I am taking a text file, which is and I need to process it. Okay, so Google Cloud Storage text to BigQuery. I need a text file, a UDF. Now let's just see what it comes up with. Like I was thinking maybe like make a JSON lines file, but I have to think about like how does it process that text file? Is it each text file or as it continuously goes here? I mean, I was also thinking maybe a CSV could be something that we would do as well. It says transform. We do need a schema, so that is correct. And we'll go ask it like, are you sure? Are you sure it's transform and not process for the function name? Unless we can name the function. Maybe that's what we can do. If we go back over to here, the UDF JavaScript function name, the name of the JavaScript that you want to use. For example, if you use a function code this, yeah, so I guess we can call it whatever we want. I don't think that's true, but I think we can name it whatever we want. So we can try this. I wasn't expecting it to work like this, but wouldn't this process the entire file? If we go here, transform line, and then it would split it and go across it. So, I mean, that's a fine example as well. We can give it a try and see how that goes. So I'm just going to go ahead and just locally save this as a text file. I'm just doing this off screen here in VS Code, so it's not that hard to do. I'm just going to call this something on my desktop here. 1 second. So I'll call this people.txt, okay? And it's trying to save it as a comma delimited one, but I'm just going to save it as a plain txt file. So what we'll do is we'll go back over to our bucket, which is here. I want to upload that file, so I'm just doing that off screen here. I'm sure you know how to upload files. I don't think it's that hard. So there's our people.txt file, which we are feeding into here. Okay, so we'll go here and we will, nope, that's the wrong one. We need to go up here and we will select here with people and then select it. The next thing is our schema. I don't know if the schema is valid, but we'll give it a go. It's also possible that we can define the schema and then get it from BigQuery. Let's find out. So I'm going to go over to BigQuery. I might still have a table from before that I need to delete. So go here. I do have a data set from before. I'm just going to delete that real quick. Okay, and I'm just going to create a new data set. So create a new data set. And here this would be my people. And we'll leave that alone. That seems fine to me. We'll go ahead and create that. And it doesn't like it when there is stuff like that. So go ahead and do that. And then inside there, we'll create a table. This will be my data. Sure, why not? And we need a schema. So the schema here that we want, let's go take a look here, is this. So we have a first name string, last name string, email string. Okay. So go back to this. So first name, I'm assuming that's all lowercase, right? Yep, it's lowercase underscore. String, required. Last name, string, required. Email, string, required. Then we have hire date. Date, required. Let's make sure that that is what it is. It's date. Job title, string. Is that required? Are they all required? Just one. Full name is not required. Okay. And then we'll do this one, required. Here we will do salary, integer required. Then we will do department string required. Then we'll do full name, and this will be the one that's actually optional. And then we have create a timestamp, which is timestamp, and that's required. Okay, so now we have all of our stuff there. That is good. We'll drop down here. That is all fine. We'll go ahead and create. So now we have our table there. We've matched the schema. I'm going to assume the schema file is fine. It seems like it's okay. And do we have to store this similar in Cloud? We do. So I'm going to go ahead and do the same thing. I'm going to save this file. I'm just going to name it schema. I'm just saving this to my desktop. And I'm going to go back over to this one. I'm going to upload that file. And I'm just looking for it. And so now we have that schema JSON. So I'm going to go back over to here. We'll browse. We'll go into here. We'll choose this. We'll select it. So now we have JSON file with the schema description, good. So next we need is the JavaScript function. We'll go back over to here into this. The function is called transform. Split the line. That might work. Yeah, it's splitting on the comma, so that should work. Depends on the data, right? But I think it should work. I'm going to again save this offline, off screen here. I'm going to save it as a JavaScript file. Let's call this function fun.js. Fun.js to my desktop. We'll go back over to here. We'll upload that file. Again, doing that off screen. There it is. So now that is uploaded, same bucket for everything so far. And then we'll go back and I will choose this here. It's interesting you can make a new one. I'm not sure what that would do if we did that because it was so easy just to make it and then upload it. There we go. Shows the code. The name of the function is called transform. Okay, so there's transform. The name of the function you'll want to use, for example, so we can name it whatever we want. Temporary directory for the BigQuery loading process. So this is just a temporary directory. So we'll go back over to here. We'll make a folder. We'll call it temp. Okay, we'll create that. We'll go back over to here. We will choose that temporary directory. Okay. The only question is like, what are we limited with the UDF? Because there is a Python one, there is a JavaScript one, but I'm curious, like, can we use anything other than just that basic transformation? The Google provided Dataflow templates supports user-defined functions. Okay. But I'm going to assume that we cannot use in here anything that like any of the APIs, because something that would be really useful here would be whether we could utilize something like DLP, right? But it doesn't seem like we can because it's such a simplistic way of working with it using Cloud DP. Storage to BigQuery using DLPT template. And this is what I'm kind of interested in. I mean, we don't necessarily have to do this, but I just want to see what this looks like. So the data masking tokenization for cloud storage to BigQuery template uses sensitive data protection and creates a streaming pipeline that follows the following steps. We are using a CSV. Calls the data loss prevention as the de-identification, writes the de-identification data into the specified BigQuery. This template supports both sensitive data protection, etc. Where's the template? I just want to see the template. And so maybe over here we can see the template. Where is the template? So here, create job from template. Oh, they're literally talking about like a tokenization template. And this is still in Dataflow. Just give me a second. I'm going to pause for just a moment. All right. So basically, when we had set this up, we had that big drop down, and it's possible I just didn't see this one here. And so within this template, maybe there are more options, but we'll proceed forward here. But it's good to know that like they already have a data flow, which will take it from cloud storage, run it through DLP first, and then insert the data, which was something when we were doing BigQuery, I wasn't sure if we could do that. And so this just, again, continuously reinforces that if we're going to put data somewhere, maybe cloud storage first. Of course, if you have data coming in from a Kinesis or something else, you might want to do that. But I would say that you probably want to put data in storage and then move it to BigQuery, because then you'd have to transform it again on BigQuery, and that would be a pain. But we'll continue on with our simpler example here. So we have our transform, our temp pipeline here. And the other one had like an asterisk. So in that other template, it seemed like you could put like a wildcard and do more here. I'm not sure if we could do that here with this template. I guess it depends on what the template's capabilities are. So here we can do it exactly once. So ensure that incoming events are not dropped or duplicated with the Dataflow pipeline. Set to use the streaming engine for streaming pipelines, automatically enabled at least once option. I don't care about that. Dataplex, I don't care about that. I don't care about any of the extra things. I just want this to work. So let's go ahead and create this pipeline. And my data pipeline 1432. Will that work now? It's not telling me what's wrong with the name. Maybe it wants underscores. Normally GCP tells you. Not all services though. Okay, I'm just trying to get it to work however I can. Yeah, what's wrong with it? You got to tell me what's wrong with it. Make sure all fields are correct, Dataflow. Let's see if I can solve what this problem is. There's obviously something to the pipeline name. Does it want a capital? Like, what does it want? It's because I have numbers in there. There's no explanation as to why. Is there something else that's missing? I don't think so. Give me a second. Let me go find out why. And here it's just still not telling us anything. Like, I've gone through all of this and it's supposedly fine. So if it's not working here, another thing that we could do is try to invoke it via gcloud, because that's the only other way I can think of that we're going to get this to work. So I'm going to open up this in another tab here, and I'm going to say authorize. Okay, because like, what else are we going to do, right? So we'll let this open here. I want the editor. Where is my editor? I want the editor. Open the editor. There we go. Okay, and mine's nice and stylish because I've been doing stuff in here. You can change yours too if you go to themes and go to color themes and change it. I just need any file right now. I'm not sure why I can't say anything. And maybe it's still loading. Okay, we got our terminal here. I'm not sure what's going on here, but I just need like a scratch pad while we're working through this. So it doesn't really matter if we don't have a file saved here. So I'm thinking like we need gcloud, and it's probably like gcloud Dataflow. And coming back over to here, I'm just going to ignore this here. Reject, reject, close, close. So this here is a pipeline we're creating, right? So pipelines. So gcloud pipelines Dataflow. And so I'm looking for it's not really helping that much. Let's go back over to here. Pipelines. Let's just try pipelines. API reference. If we go here, we might be able to find. I found it before, and it shows me like the whole list of everything. gcloud. We'll try something like gcloud run first. Because if we do that, even though it's not what I'm looking for, that I might be able to find the reference to everything. There we go. So if we go here, the Cloud SDK, now what we can do is find what we're actually looking for. So I wonder if there's like one called pipelines. No. We have Dataflow. So we can expand that. Overview. Better decides to load here. Command groups lets you use Google Cloud Dataflow resources. So we have flex templates, a group of subcommands for Dataflow flex templates. See, I don't know. Is that pipelines? Like, because it's called data flex templates. I can't make sense of that. Allows you to package a data pipeline for deployment. That's what that sounds like, right? Okay. So that kind of looks like what we're seeing. So let's go back over to here where we had all the provider templates. And in here, we'll find the one that we were just trying to do right now. So the one that we're trying to do is to BigQuery. It's like Google Cloud or Cloud Storage text. And there's a few of these here. This one right here. So this is the one that we're doing. And so here we can check whether some of our files are wrong. So looking at our schema, our schema file is supposed to say this. So it clearly is wrong. Also, it's wrapped with square braces, which actually makes sense. That's fine. So I'm going to go see if I can fix that first, because maybe that's just our problem, is that we're not following the correct schema. And if we get it working console, it'd be great. But you probably get more information from the console about like what's wrong, and that'd probably be a lot more less frustrating. So I'll just save that, and then we will go back and upload that again. So we'll go over to here, and I'm just doing this off screen, of course. Schema, so we'll say open, and overwrite this object, continue uploading. And so now we've re-uploaded that. I'm going to go ahead and try and save this now. Still doesn't work. That's totally fine. But we definitely fixed that issue. Here's an example. It returns it as a stringified JSON. It does the same thing here as well, so I don't think that's an issue. And we can provide whatever name we want, so that's fine as well. We don't actually have to call it process. Okay, so let's go over to gcloud here, and then we'll just replace this stuff. So the job name can be whatever we want to call it. So we'll just call it text to BQ, and we'll just put some numbers here on the end, just in case that's an issue. The region we're in, Dataflow templates. It's only available in certain regions, probably. So like we probably want to do like Montreal region, GCP name. Just don't want to type it out. It's so darn long. There we go. Northeast, North America, Northeast 1. There we go. So I'm going to go ahead and update that like that. I don't know what other versions there are. I would assume that there's only a single version. Let's just change this to version 1. We'll have to find that out here. Do they specify versions anywhere or show you where it is? It says template source over here. Well, at least we can see what it does underneath. So here's the template, which is kind of interesting. It's just saying what it requires. And then here, oh, we can do apply, transform. That's interesting. Okay. So maybe the template itself is what can contain the DLP stuff. So we can integrate with Google APIs, but it's via the template, which is a lot more work. But anyway, this is correct. Though here, ensure that the top level stuff is here and follow the pattern. One thing in here is that we don't have this mode. It's not showing it there. So I'm going to just take that out. But wouldn't you have that? Like, how would it know then what to set it as? Yeah, this seems a bit fishy to me. But let's keep going down here. So we'll just say version 1, even though I have no idea. The JavaScript function. So I would assume the version of the template that you want to use. Low, we can just say latest. Okay. We'll change that to latest. The region name. We filled that in. JavaScript function, the name of the JavaScript function defined that you want to use. Okay, but I'm guessing it's the GSS path. So let's go back over to here, and we'll just grab this path here. It's not specifying whether I have to put GS. Well, it does say GS path in the front, right? So if I do this, yeah, then that would work. Okay. And then we have the one for the schema. So it's going to be schema. Wait, what's this for? Yeah, I think it is that schema. And this is the function name, which is called transform. Path to text data. So very similar, but this is people.txt. The BigQuery table, which is called my table. Yeah, did we even specify the table in here? Yeah, how does it know where it's going? I was just thinking about that. So carefully looking at this, we have the source, right? To BigQuery stream, yeah, but how does it know where it's going? So maybe we are missing data. 1 second here. 1 second. Oh, you know what? See here? Drop it down. That's what we couldn't see. It wasn't even obvious that we couldn't see it because they don't highlight in red. So a little bit of a UI issue here. So maybe that's our big problem. It wasn't a big deal taking that detour. I think we learned a little bit while doing that, but we have my data here. Okay, so everything's now green, and we did correct some things along the way. Hopefully it works now. Okay, and so we are now just waiting to see if this execute. It might fail, it might work, we don't know. So we will just wait till it's done, okay? I assume what it's doing is provisioning a virtual machine, as that's what it was suggesting before, that we would configure something on Compute Engine. So we're just gonna wait for this to complete, okay? All right, so the job has been processed. Notice that it says that it's active, and that's what it says, it's streaming. So I would imagine that if we were to update the file, it would process it again. One thing I don't know, oh, it looks like it failed down below. Let's take a look as to why. Probably because there are adjacent JavaScript functions wrong or something. Is it going to tell us? Execution details. Let's take a look at our error here. Failed to launch the virtual machine. One or more operations had an error. Does not have enough resources available to fulfill the request. Try a different zone. Oh, geez. Okay, so that's interesting. And this is something that has happened to me before with the Montreal region specifically. I don't know. I always think it's like just one of the zones, but I don't know. I guess we'll have to run it again and see what happens here. So I'm just trying to think, can we just trigger it again? Trigger. No. We're going to have to update it to make the job occur here. So what I'll do is I'm just going to go ahead and delete one of these lines out here. Or you know what? I'll just duplicate it. Boom. Now we got two of those lines. And I'm going to go back over to here. I'm going to re-upload the file, and we'll see if it re-triggers it. But at least it wasn't us that caused the issue, right? So here I'm looking for people.txt. And we'll overwrite the file. And so we'll go back over to here. And what I want to see is if a new job is now occurring. Let's give this a refresh here. I think we have this tab here as well. 1 second. So we'll go into our pipeline. I want to see if it's trying to run another job. It's not. And maybe the issue here is the fact that it wouldn't know if there's, like, if we override a new file, would it pick up a new file? Maybe not. So I wonder if we can stop this, stop the pipeline. Can I edit my pipeline? It's weird because it looked like we could edit it. Can I clone it and then just modify it? There we go. Okay. So here, template path. Yep, that's fine. Streaming, etc. I'm gonna try to put wildcard here instead. Okay, and so hopefully this way we'll be able to have more options. Let's see if it'll let us do a wildcard. Okay, maybe we just got to rename this here. So I'll just take out the crazy name like that. We'll go ahead and create this pipeline. And so now we have this new one. The question will be like, if we drop a new file, would it pick it up? But let's see if this one has less of an issue. The job is completed. It still failed. This is very frustrating. I'm going to stop it again. I'm going to clone it. We're going to move it to somewhere else because Montreal's having some trouble here. We'll go to Iowa. We'll leave everything else alone. We'll say create pipeline. Assuming that it wasn't that asterisk that was causing the problem. So now we're totally running it in US Central 1. So maybe we'll have less of an issue here now. Okay, and we'll just wait to see what happens. All right, so this one finished and it failed as well. Let's go take a look and see what the issue is. I can't imagine it's availability. It must be something else. Let's go down and take a look at the error. One or more operations have failed. The zone does not have enough resources to fulfill the request. What? Try a different zone or try again later. What is going on here with Dataflow? Capacity in the zones to run the job. Try a different zone. So that's assigning zone. Use a regional endpoint for your Dataflow job. This allows Dataflow to automatically select available zone in your region. That would be really nice. We will try this again. And go back here to our pipelines. We will go into this one. Why have the edit button if you cannot do it? Okay, we'll stop that pipeline, we'll clone it, and let's go down and see if we have more options. So what we're looking for is an option to say like, hey, choose an available zone. I don't know how it would do that. Worker region, worker zone. So use jobs regional endpoint. Auto select. So we'll just set it to auto select, and this way, at the very least, we'll have less of a problem here, right? So now there's no way it would choose the wrong one. This is US Central 1, which has a lot of zones. We'll go ahead and create it. Oh, I know you don't like that. We'll go back up here and change it to 2. And we'll go all the way back down to the bottom. We'll try this again. So now we should be able to avoid that problem. If it errors out, it's going to error out for a different reason, right? So we have this pending, and we'll wait to see what happens. All right, let's take a look here, and maybe it failed again. It did fail again, but we, at least this time, know that it's not going to be because of zonal issues. Does not have enough resources, but it's choosing what it wants to use. Give me a second, okay? All right, so it looks like this is an extremely common problem, and this is even 6 years ago that people are complaining about it, and I'm just getting tons and tons of complaints about this. So I don't know. This is not great, but I mean, we can generally understand exactly what the service is going to do. I don't think there's any reason for us to continue forward here. We have a general idea. The most important piece of information that we got out of this was that we can use a Dataflow pipeline, and it has a template for data loss prevention so that you can mask data before it makes it to the final entry. I think we have a general idea on how this stuff is going to work, so that's totally fine. We'll just do a little bit of cleanup here, and we'll call it quits. Not everything works, and that's just how it is, okay? Could we use Dataproc instead? Maybe. That's a lot of work to set up and use, but we will call this one done, and you can't win them all, right? So go over to here. We'll get rid of the bucket. What's all these buckets? Why do I have all these buckets? Let me go over here. Run sources. I didn't know I had all these from before. Services. I have no idea why I have so many buckets. I am going to get rid of this one, and these other ones I'll get rid of here. But anyway, actually, I'm just going to get rid of all these buckets. I have no sensitive data in my entire thing here, so it shouldn't matter. So we don't have to empty the bucket. That's something that's always been a headache for me. But anyway, we are all done here. I will see you in the next one, and that's Dataflow, okay? Hey, this is Andrew Brown. In this video, I want to take a look at the DLP API, which is under the Sensitive Data Protection product. If we go over to here, I don't know much about these other ones here, but the Cloud DLP API has been around for a long time, and it's something you absolutely need to know for your exams. And so what we should probably do is if we open up the docs here, we should go ahead and implement it. Now, even though they do have Ruby as an option, they don't provide the instructions here. And it was too hard to figure out how to get it to work. So we'll just go with Python. Today, I'm going to go ahead and implement this within GCP, within Cloud Shell. I think we can probably do it all within there. So we'll go ahead and click the Cloud Shell button. And I'm going to open up the editor as I'd like to switch over there. And I'll pop it up over to the other screen, and we'll just close it over here. And you can already see mine's themed a little bit differently as I took a little bit of time to do that. I don't need the bottom part, as the editor will have the terminal in here. If you want to change your theme too, go to the bottom here and go to themes, and you can choose a different one. I'm on Molokai. But anyway, what I want to do is make a new folder here. We'll call this DLP. And I believe that we have Python installed here. Let's take a look here what version we have. We have 3.12. So we're going to cd into our DLP directory here. Let's go over to our docs, wherever it was here, and we'll go over to Python. And so here we need to install, I guess they want us to install an environment, which I don't know if we can do that here, but let's try it anyway. If we can, that's fine. I don't think we really need an environment, but we will go ahead and do that anyway. And if we go here, notice that we have the environment exactly within here. So it's a little bit messy, but that's fine. Okay, and so we've now activated that environment. From the DLP directory within the cloned or unzipped Google sample directory, install this. I wasn't going to do it that way. I guess I have examples over here. So let's take a look at the requirements here. We just need DLP. There are other ones here, so technically we could grab all these. I don't know if we really need all of them. So I'm going to go here and just make a requirements.txt. And then we'll go ahead and paste these here. I'm going to do a pip install -r requirements.txt, because there are services that can integrate with DLP, and maybe that's why they're being included here, but we'll go back over to here for a moment. Let's take a look and see what we have. So we have that there. Okay, we have a quick start, but I really just want a simple example, as it can get really confusing when we have so much stuff there. If we go down below, here seems to be a simpler example. Let's go ahead and copy that. We'll go back over to here. I will just make a new file called main.py. Okay, and we'll paste that in here. And so this in theory should work. So what do we have? We have contents of a name. Here we are specifying the info type that we are required to look for. We are checking its likelihood. We are matching against it, and we are going to see what we have here. But hold on, let's just carefully read this. So initiate a client, string to inspect, construct the item to inspect, include the info types to search for in the content required. So we can look for other things, but here it's just checking for first name, last name. The minimum likelihood to constitute a match. So here, likelihood unspecified. The number of findings to report, 0 for the server maximum. Whether to include the matching string in the result, optional. Construct the configuration directory. Convert the project ID into the full resource ID. Do we have a project ID here? I don't see that specified anywhere here. Call the API. Print out the results. Okay, so this might not work initially, but let's go ahead and just try to run it and see what happens. Oh, sorry, Python main.py. And so that's what I thought was going to happen, is that we don't have a project ID in here. So I like how they give you incomplete code. We'll go ahead and go here, and I'm going to go back over to here. I'm going to choose this one here. We'll go ahead and we'll try this. And it came back, and we got Robert, first name, likely, Frost, last name, likely. So we could probably change this stuff. I'm going to see if there is an API reference here. Because what I'm looking for here is the info types. DLP API. So here we have other ones like, there must be more than this. Go over to here. Ah, here we go. So here's a bunch. So maybe like we'll try credit card number. That's a pretty common one, eh? Credit card data. And I'm going to go back over to here. Lives in Canada and has a credit card number of should be able to get a fake example here. So here we go. We'll just grab this one. And we'll run this again. We'll see what happens. Here it has a problem. Oh, I guess literally this also has to be correct, eh? Oh, name. Sorry, name. I thought it was some kind of mapping. 1 second here. And so here we can see now we're matching against this one. And so it's finding that information. So that's how that works. The question is like, how does it integrate with actual other services? Now, this example here seems to be including a bunch. So it makes me think that maybe somewhere here, one of these would actually show that. Let's go over to Redact. I'm just picking one at random. And so what I'm just trying to find here is, are there any ones that actually use any services? Nope. That one doesn't. Triggers. Yeah, so I'm not sure about the API point, but let's go figure out if there's a way that we can use this integrated somewhere. So just give me a moment, just a second, okay? All right, so here it says using sensitive data protection to scan BigQuery data. So if we go down below here, it looks like we can enable the API, which it must be already enabled. If I don't have it enabled, let's go ahead and take a look. Okay. I mean, it obviously worked before, so it must be enabled, but if not, it will definitely be enabled now. And so here, the idea is that a service account is created with the name similar to the project name. The service account is granted the DLP API agent. That's fine. To scan a BigQuery data, you create sensitive data protection job and analyze the table. You can scan a BigQuery quickly by using scan sensitive data. So let's go set up a BigQuery database. So that's kind of interesting because we could, but I guess the question, like if you had the data in there, it's not like it would not be in there prior to it. And so this is something that might matter where it's like, okay, you have data, you're moving it, you're trying to move it into BigQuery, but maybe you don't want in the final destination for it to actually look like that. So that might be an issue that we might have. What I'm going to do is go ahead and create a new data set. It should be like my data set. It can be multi-region, sure. Link to external data set. I don't know about that. We'll go ahead and just, oh yeah. Whatever, we'll just go ahead and do that. And so now we have created ourselves a data set. I'm going to go ahead and create a table here. This will be an empty table. Obviously, we could bring data in from anywhere. So it'll be my table. And going down here, this seems fine. We don't need partitioning. We'll add a field. So this will just be name. We'll just be like description. Okay, and string is fine. So we'll go ahead and add a string. We'll create that. And so now we have this here. And what I want to do is add some data. So I'm just taking a look here. Can we add it directly, or do I have to write it as a query? You could probably open it up as a notebook here. Okay, so we'll just open up a new query, I guess. And there should be over here, yeah, here we go. Insert mock data that would into the description field. Insert 20, or let's say 10 fields with some data containing mock PPI and sensitive data. Description field. Let's see if it can do this. We'll give it a second here to try. I think we can insert here. I notice it even says this, right? This contains sensitive information. That is our goal. This is what we want to do. Yep, that's fine. Let's go ahead and do that. And we'll run it. We do have a little bit of an error. I'm not sure why. Insert into. line 3 of 8. So we'll go ahead here, and I'm not sure what the problem is. We'll go ahead here. This is a query for GCP, BigQuery. Because I do not want to figure this out here today. I can, but let's just... I get this error. Let's see if we can just get it to solve it for us quickly. Yeah, that's what I didn't understand, the whole select there. It looked really confusing to me. So let's go ahead and remove it. I thought that was really unusual, but I didn't know that was like some kind of special thing that's going on there. All right, we do have the description, so maybe we just take out that, and that might resolve our issue. Yeah, why would we even have a limit here? That also doesn't make any sense either, right? Like that looks like a normal query. Now we'll run it. And I do believe our data is now inserted. Let's go take a look at our table and see if we can see it. They say Table Explorer. This always says empty, so I'm not really sure what's going on here. But now we can see our data. So the idea is that we want to scan this and see if there are any issues. I'm going to go back to the top level here. I'm also just checking if there are some intermediate options here. Okay, yeah, close, close. Okay, so now that we have that, let's go back over to the sensitive protection, data protection here. And I want to run a scan. So here, what did they say it was? If we go back over to here, in BigQuery panel, in Explorer panel, click Export, Scan with Sensitive Data Protection. Okay, so we'll go back over to here. Are we not in the Explorer panel right now? Where is this Explorer tab? Oh, it's over here. Yeah, we are in Explorer. Okay. So we're looking for export. And that's why I was looking here earlier. I thought there would be something, but... Give me a second, I'll go find it, okay? All right, so all I did is I went back to my table here, and there's an export option here. But this is going to a bucket. So that doesn't seem the same. Here we have data quality scan, that's not what we're looking for. Let's go back over here to the instructions. So in the Explorer panel, expand your project and data set and then select the table. Click Export, Scan with Sensitive Data Protection. Export. And okay, but that's to export to Google Cloud Storage. So that's not really going to help us. Just a second here. So there's conflicting information where there's that export option, but there's also, it's saying here that you can create jobs, inspection jobs. And so I would expect that, and it's saying it's somewhere here in sensitive data, but I mean, that's the old one. Let's go take a look at this one. Can I even click on that? Does that do anything? Nope. It's the same thing. So I would think that somewhere in here, we don't want discovery. What if we go to deep inspection? And this is inspection, so this must be now the way to create inspection jobs, which is not very clear, but that's okay. We'll go ahead and click this. And we only want to do this one time, so just say my DLP check, right? Do you want to scan across multiple cloud storage and BigQuery tables? Try discovery, which is not a bad idea. So I mean, like this is running a job, but this sounds like discovery would be doing it all the time. We'll go ahead and do BigQuery, and we'll place in our ID here. I like how some services, they let you easily search for stuff and other ones they don't. I don't know why they do that. And so now what I'm doing is manually specifying my data set. So go over to here. Okay, and then manually grabbing this here. Okay. No sampling, I want all the data checked. There's not a lot of data here. Inspect all columns, yes. We'll continue. You know, my template. My template. A valid template resource path is required and can be found in inspection template details. Oh, okay. Templates are an optional way to use a single source job. No, I'm going to ignore that. So here we have info types that we're looking for. Okay, cool. Add hot words or exclusion rules. I don't need to do that, but that's fine. Confidence threshold. So likely. Let's put likely. We'll continue further. Select the actions which you'd like to take after the job is complete. Specify a BigQuery table to save the findings. If you don't store the findings to either BigQuery or Cloud Storage, the job will only contain statistics about the number of info types. So I guess we could dump it somewhere. I guess we could do Cloud Storage here. I'll go ahead here and take a look. Maybe we already have an existing bucket that we can use. You can also just make a new bucket. It's not like that. It's that big of a deal. Okay, and I do have this like migrate bucket, so I'm going to go ahead and use this one. As you can see, we were using it before for something. I don't know what it was for anymore, but we'll go ahead and delete it. Again, you can just create a bucket here. I just already have one, so I'm just going to use what I already have. And we go here. Yeah, we can get the full GS util name here. We'll go back. We'll paste it in like that. And I'm going to go down here, we'll hit continue. We can schedule it, or we can do it one time. Run the one-off job. Yeah, so we can put it on a schedule, obviously, right? Daily, monthly, custom, whatever. We're going to just run it one time. We'll hit continue. Here's our job configuration, which is cool that we get it. That's fine. We'll go ahead and hit create. This is a very small data set, so I'm not worried about it. If you don't want to do this, don't run it. The caller does not have permission. Okay, so what I'll do, I guess there's like, this is inspection job. Obviously, there's some kind of permission we need for this. We're almost able to do it. Is this for the inspect data using Google Cloud? That's not it. Okay, so we'll do this here. I need to know what permissions I need, though. Let me go figure that out. I've gone over here to IAM, and I'm just trying to find what the appropriate thing would be. So the service is called like sensitive. So I'm going to go over there and see if we can find it that way. Sensitive. I don't see it there. Type inspection. Nope. DLP. Including jobs and administrator. I mean, like technically we're running a job. So I'm going to go ahead and try to assign myself that role. Let's see if I can do it now. Let's go back over here, hit create. Is that what I needed? Look at that. Usually I don't get the role. I usually have to look it up. So I'm really surprised I was able to guess it. So now it's running. Again, I don't expect this to be very expensive, but we'll go ahead and do that. And we'll wait till this is done, okay? All right, there. So there we go. It scanned, and that was really good. It was telling us to use discovery earlier on, which I'm not sure as to why. But let's go take a look at that storage bucket so we can actually see the results. I'm assuming what it's doing is it's actually showing us what's stored within the bucket and reading it from there, because earlier it was saying that if we didn't provide it in a bucket, we would just see how many and not how much. So if we go into here, is some kind of file. Let's go ahead and download it. Let's see what the contents looks like. I'm going to go ahead and open this up in VS Code. Just give me a moment. Yes, I do have VS Code open. Just a moment. So if we go here and take a look. Yep, so it's a big JSON structure. Okay, cool. But yeah, I'm just curious about discovery because they're like, yeah, if you have discovery, this is probably just like continuous stuff, right? Here, so data profiles provide metric access for what's sensitive to your data. This dashboard shows where data discovery is enabled. So you can enable it for very specific services, right? So we go ahead and enable it. We could say enable it for this. Maybe scan one table. Again, we could do the entire project, I suppose. It's not like there's much in here. And we'll hit continue. And sure, we'll use the default one there, continue. Okay, and I'm not going to go through this whole thing, but basically what it looks like is that it's just like continuous scanning. It's continuous scanning, it's continuous discovery. I don't think there's much for us to do here to find out. It looks like we can set up a Looker Studio dashboard, so that's kind of interesting. But my question is, like, if you're setting up a pipeline and you don't want this sensitive data to be there in the first place, then what would you deal with it? Like, that's my question, right? Or I guess the thing is, like, there's always a chance for that to happen, so you'd have to front this before something. Just a moment here. Let me think. So this is what Cloud is suggesting. And basically what I was thinking was that you'd probably put in cloud storage first. That's what I was thinking, because I actually got an exam question on the Pro Architect, like, where would you put it? In my head, I would go, I would put it in a bucket first and then make a trigger, which would then, run it against the DLP API, and then it would insert into BigQuery. That's what I would do. And that's basically what it's suggesting here. Club pub sub with Dataflow to pre-process streaming. So it might be interesting to look at Dataflow into BigQuery and see how we could set up that pipeline. But for now, I would say that, and there's also data build tool. I don't think I've ever used that. Let me take a look here. I thought that was going to be GCP specific. It's not. Maybe it is. Yeah, it's a third-party tool. A visual data preparation tool that lets you clean and transfer data through a GUI interface before sending it to that. Is that never mentioned data prep on the exam? So even if it is here, I can't imagine we'd use that. It's in the data studio. Okay. Where is it? Where is it? Where is it? Where is it? That's what I want to know. Yeah, so I'm not really sure about that, but we probably should take a look at Dataflow in a separate video. But I think for DLP, we've kind of figured out what we'd like to do for that. And obviously, the inspection jobs work for both cloud storage and BigQuery, so that stuff is solved. I'll see you in the next one, okay? Ciao, ciao. Let's take a look here at Google Cloud Storage Fuse. It's an open source binary that will allow us to mount Google's Cloud Storage bucket to Linux operating systems. So you do have to give it some authentication for like application defaults. But once you install this binary, which is really easy to install, you just have to type in GCS Fuse, give it the bucket address of what bucket you want attached to and its mount point. We have a follow along to show you how simple and easy it is. And then once you mount it, it's like a mounted drive. So you can write files to it and you can read files to it, and it virtually maps over the structure. It's not using POSIX underneath, so there's probably some simplification there that you wouldn't normally get with a full file system. But the point is that you can mount it. It apparently directly integrates with other GCP services. I haven't tested this myself yet, so I can't say for certain as I show you how to mount it to a virtual machine. But the idea is that it has direct integrations with other GCP services. It has 4 levels of caching, which you don't need to know for your exam. But the point is that it does have caching involved so that it can make it pretty quick for some use cases. You can read and write to the mounted cloud storage bucket, so you can write to it. And I was trying to figure out like when and why would you use this? There are very specific cases, I think, with like Vertex AI, or maybe it's like hypercomputer. I spelled hypercomputer wrong there. But I think like they recommend when using AI hypercomputer to use GCS Fuse. But like their description in the docs is like, use it when it makes sense to use it, which doesn't really help us to understand it. But the point is that other providers have some kind of similar feature. Both Azure and AWS have this way of mounting their buckets into drives or like onto their virtual machines as virtual drives. And so Google has this feature as well. Just be aware of this feature. And you will see maybe on the exam like GCS Fuse commands, But the configuration, like the options, like the flags, aren't going to really matter that much. Just you generally have to know, like you have this, you got your bucket, you got your mount point, and you'll be good, okay? Hey, this is Andy Brown. In this video, we're going to take a look at Cloud Fuse or Cloud Storage Fuse. It's a way for us to mount cloud storage buckets so that we can use them like a mounted drive. So let's go ahead and take a look here and see how we can do that. So obviously the first thing we'll need is a virtual machine. Let's go ahead and spin one up. The default one is Debian, and luckily here we have Debian Ubuntu instructions under here. So we'll do our best to kind of work our way through here, but I'm going to type in Fuse VM. And I'm going to launch this in Toronto in it doesn't really matter what region, or sorry, zone, but I'm going to be particular about what I choose here. We'll choose E2 Micro. We'll go ahead and create that instance and let it spin up. Let's go make our way over here and take a look. So it looks like we will need to install the package source, import the key. If your distribution outdated, so these are separate steps. Sometimes they do this where they'll have like two steps. So we'll take the first two here. And then it looks like we should be able to install it. So let's go back over to here and see if it's ready. Generally, it's really fast. As you can see, it's already spun up. So we'll go ahead and we'll SSH in here. And we'll get this going here pretty quick. Now, there are cases where, I guess it's just convenience. Like there apparently is like a lot of caching options for this project. It is an open source project. I'm not sure if it's originally by Google or not. But you know, I think there will be cases where you don't want to use this because of convenience, or there could be other cases where you want to move your data to something like Firestore for better performance. But I'm just grabbing those first two steps here and pasting them in here. There we go. So now we have the key. So if we scroll on down here, I should be able to do a sudo apt get update, which will take a little bit of time. And then we will go ahead and attempt to install Fuse here. I just keep moving the window off screen so I don't lose it. We'll go ahead and hit enter. We'll say Y for yes. Okay. Never done this before, but I imagine it's easy. Both AWS and Azure have a similar offering, so I can see why Google would have something as well. So this is about upgrading, so we'll ignore that. Install or upgrade Cloud Fuse by using the latest storage. No, I mean, it's already installed. So now the next thing would be how to mount a bucket. So while that is installing, what I'm going to do is I'm going to go over to cloud storage. And I don't know if it has to be in the same region, but maybe we'll do that anyway. We'll put somewhere similar. So this is my Fuse bucket. Okay. And then we will continue. And I'll just put some numbers here on there on the end. And so I want to choose a single region. I don't need it to be everywhere. I'm going to put it in Toronto, because again, I'm just doing everything in Toronto here. We'll hit next. Standard is fine. Continue. I think this is fine. We'll go ahead and create. Yep, that's fine. At this point, that will be fine. We'll create that bucket. I need an image, so we're just going to type in Star Trek. And I'm going to go here. And we will grab Star Trek. Yeah, we'll grab very old, we'll grab TNG. Everyone likes TNG. So we'll go over to here. I'm dragging this off screen and I'm just naming this image here. Star Trek. Is this not even a PNG? What is this, an AVI? AVIF. I mean, I haven't seen that file type in a while, but that's fine. We'll go ahead and I'm just going to upload. You can see I have a lot of stuff on my desktop, but I'm just going to go here and upload this single file here. Okay, so now we have that set up. We could also make a folder here and just call it Star Trek. I wonder if we could just easily move that here. Can I drag that? Can I move that? Move. And I'm just going to drop it in like that. There we go. And just putting in a folder because I know when we mount this, it's going to maintain some of the structure, and I figured that might be a good idea. So to mount and access the bucket, you first have to do the following. To mount, access, perform read-write operations in a bucket, ask the bucket owner to grant storage object user role on this bucket. Okay. The bucket owner. So I'm not sure if we have to do that right now. We'll continue on. You might also be able to do this. Install, we've already done that. Authenticate Cloud Storage Fuse requests. To authenticate requests, you must set up the application default credentials. By default, Cloud Fuse automatically loads existing default credentials. So we'll have to install the CLI. Oh, wow, we really got to go and install a bunch of stuff here. Okay, so is gcloud already here? Let's take a look. Be nice if it is. It is, excellent. So I'll just hit Q here, and I don't know if I have to do gcloud init here. I'm just gonna go gcloud auth application default login. Let's see if we can do that. We'll say yes. And I'm gonna copy that link here. Copy. And then we'll just paste it in. We'll do it this way. Say continue, continue. And I will copy the verification code here. We'll right click, paste, and hit enter. And so now we have our application defaults credentials set up here. So here apparently we can mount the bucket. So there are global options. I don't really need any options here. Let's take a look at what we have. So we have anonymous access, app name, disable authentication for requests. I don't necessarily want to do that. Client protocol, config file. You know, the question is like, what do we need to have? Right? It'd be nice if they just told us. But here we have a lot of information. So I'm going to go back all the way to the top here. I'm just going to try to work our way through this and do our best. But there's obviously a mount point, and so in the directory where the bucket will be mounted. So let's go ahead and grab this bucket name. Okay, and we'll go back over to here, and we'll just try to reference this. And I've definitely seen GCS Fuse commands on the exam, at least for the Pro Architect. So, you know, knowing these commands is probably important. So we have bucket name. I don't need any global options, but we'll say bucket name, and then we'll say mount point. So I'll just say mount Fuse bucket. See if that works. And it doesn't look like it worked. Quota was added to the, no, that's not it. Error when mounting GCS Fuse. No such file directory. So I'll just make the directory. So I'll type in mount Fuse bucket like that. And I will just give it a sudo. And I will chmod it with u plus x. I don't know, I'm just trying to give it any kind of access here. Just say sudo. We'll do ls-la mount. It says it's still root. And who am I? So here I might want to change the ownership. I'll just say change. We'll show this. Say Andrew. Okay, because we just want this to work. We'll just have to sudo that. There we go. And so now if I ls that directory, so I'm thinking that now we should be able to mount it. So we'll go back and hit up until we get back to that mount command. Again, never done this before, just using my tech skills to figure it out. And file system has been successfully mounted. Cool, let's go ahead here and take a look. So we'll go mount. I really wasn't expecting it to be that easy. There it is, okay, we got the Star Trek folder, little CD into Star Trek. Okay, we'll cat out that, which will give us a bunch of junk, good. I'm gonna touch a new file here. I don't know if I can write, let's find out if I can. Looks like I can. Let's go over to here and take a look and see if that file actually exists now. Give it a hard refresh here. There's a refresh in the top right corner, I missed it. Click into that. There it is, okay. I'm gonna write to that file. It says 0 right now, but we'll go ahead. Okay, we have a Japanese character there, I recognize it. Not sure why it's Japanese, but that's fine. We'll go ahead and we'll do this. Type in hello world, and we'll do right quit. We'll go back over to here. Let's take a look here and see what we have. Refresh. So what I'm looking for is just to see the byte size change. There, it changed. So that works. That works. That was pretty darn simple. But yeah, there's probably options that we probably want to know about. Let's go over here. Let's just take a look here. So anonymous access, billing, cache directory. Probably knowing the types of caching is probably important for different types of architecture. Looks like it's logging. Yeah, so probably the only thing that I'd probably just add as additional information is probably caching levels, because that could play into different architects. But yeah, I would say we're done here. I'm going to go ahead and empty this bucket. Okay, and then I'm going to go back up a level. I don't know if I even have to empty it. I just, I'm so used to doing that on AWS that I just, as a habit, always empty it first. We'll go ahead and delete it. And so now the server's only, oh, there it is. Okay, it's great. It's gone. Let's make sure the virtual machine is gone. I'm not sure if I spun it down or not. I'm talking, so I'm not paying attention to what I'm doing. We'll go ahead and we'll delete this. And there we go. We are done. And that is GCS Fuse. What was the initialism? GCS Fuse. There you go. Ciao, ciao.